Hello and welcome back to the next part of Unit 2. This is talking about Target 2 and 3, but we renamed them 1B and 1C going forward. We're going to solve single variable linear equations with multiple steps. And of course we get into one of our favorite F words in math, fractions. So what's the difference between what we did the other day, 1 and 2 step, and what we're going to do today? It's a great question, Mr. Reitman. I'm glad that he asked. Right?
That's a really good question.
All that means is we're going to be able to apply different properties first. For instance, we may have to distribute on one side or both sides before we start isolating the variable. We may work with combining like terms, variables on both sides, and then of course the fraction part. We just include that in here too because it's just so much fun.
So the first thing we're going to look at is use of the complex questions with parentheses. So before we can get x by itself, we need to be able to simplify what's in the parentheses. So you have an example, 2 times x minus 4 in parentheses equals 24. So what you do is you multiply the outside by the inside. 2 times x gives you 2x. 2 times negative 4 gives you negative 8. And you have 2x minus 8 equals 24. So we use the distributive property to get rid of the parentheses.
Now, at this point, I believe this looks very similar to what we did the other day.
It really does, actually. And what we're going to do is you want to get the numbers onto the other side. So that negative 8, how do we get rid of it? Well, we do the opposite. We're going to add 8. So we're going to have 2x minus 8 plus 8 equals 24 plus 8. So that'll give us 2x equals 32. Divide both sides by 2. And we have our answer of x equals 16. It's always good, again, to put that x back in the problem just for a check. So 16 minus 4 is 12. 2 times 12 is 24. We've done the problem right.
All right, so the next problem we're going to look at is what if we have like terms on the same side? Here's our example, 3x plus 7x minus 53 equals 77. So at this point, we have to think, what should we do first? We have to isolate the variable, right? That's our goal of solving something. We want to find when the left side equals the right side. But right now, before we can isolate the variable, we have to get them together if we can. So there's a 3x and a 7x on the left side, and if we can actually combine those, they are like terms. Again, a review on like terms, they have to have the same variable, the same number of variables with all the same degrees. So be very careful on what is a like term and what not. You can always refer to other previous videos on like terms that Mr. Dowell made for you guys. So we're going to take the left side, we're going to add our like terms, and look at they're even a different color for you to see that. 3x plus 7x gives you 10x on the left side. Now at this point, we do have a two-step equation. So just like we did on the last slide, just like we've done before, we now want to get rid of the number on one side and keep the variable on the other side to isolate it. The opposite of subtraction is going to be addition. So we add 53 to both sides. We simplify that, and now we're left with 10x equals 130. 10 times x, we must undo multiplication, so we would divide. We divide both sides, and we get our answer of 13. Now, Mr. Reitman, if we take 13 and we plug it back in and we substitute it into the x, into the original equation, what do you think happens?
I think it would check out perfectly, because if I did 13 times 3, that's 39. I have 7 times 13, that's 91. So 39 plus 91 is 130, minus the 53 is 77. So we'd have 77 on the left side and 77 on the right side.
Sounds good to me.
Now, we have something called VOBs.
That sounds awesome.
VOBs. Maybe you'll remember it better as variable terms on both sides. So we have terms on one side, we have numbers on one side, we have terms on the other side, and numbers on the other side. So before we can get x by itself, we need to get the variable terms to be on the same side. So let's start out with the first part of the process here. One way we could do this is to get rid of let's look at the two variables. We have 6x and 2x. So what we can do is let's subtract 2x from the right side and 2x from the left side, and what we're going to have is 4x plus 15 equals negative 33. We now then have a two-step equation that we already know how to solve. Right? What are we going to do? Yeah, that's right. We're going to add 15, we're going to subtract 15, pardon me, from both sides. That'll give us 4x equals negative 48, and x then equals negative 12 when we divide both sides by 4.
It's almost like it's on the screen. Isn't that weird?
Oh, it's crazy.
Now, you're probably wondering, and if you're not, well, this is something interesting to think about is, well, do I have to subtract 2x on both sides? Or what if I wanted to subtract 6x on both sides? That is absolutely okay, and you can do that. By doing that, you get negative 4x on the right side, but because now the x is on the right side, you would need to take 33 and move it to the left side. It's going to work out the same. Your answer is going to be negative 12 equals x instead of x equals negative 12. But for all intents and purposes,
You know, and I think with all of our examples that we talked about too, most of them have been variable on the left side. So for consistency purposes, maybe you want to keep just the variables on the left side, the numbers on the right side.
not a problem. All right, so the next example you guys are going to kind of do on your own right now and try to do this one. This is putting everything together. So take as long as you want to. You can pause the video and then come back. So pause, probably, maybe.
Now,
And we're back.
We are back.
Left, and Mr. Wright just stayed here the whole time. So anyway, as you go through this, we have to look at what's happening on the left side, and then what's happening on the right side. You notice the left side we had the parentheses, so we probably use the what's that property, Mr. Reitman?
Distributive property.
Distributive property. So we're going to distribute the left side, so we get the 6x plus 36. And then for the right side, we see now 4x and 6x kind of in that purplish magenta color. Thank you. And then we're going to be able to combine like terms on the right side to get 10x. 4 plus 6 is 10. And then after this, we have now the VOBS type of a question where we have variables on both sides. So in this example, the one that you're actually going to look through is moving the variable to the right side. Now, why would we do this? There's different reasons for this. The way that when we have conversations, the bigger number kind of is the one that wins. Think of War, if you ever played that card game War and everything else. That way, you actually don't have to worry about negative signs. 10 minus 6 gives you a positive. You could move 10 over, but then you'd have negative 4 instead of positive 4. Which again, it does not matter. You will get the same answer as long as you don't miss any of that other math arithmetic that's in there. So now it's a two-step equation. We're going to be able to get rid of the 8 to both sides by adding it. And then we have multiplication. And then to undo multiplication, it's another D word.
Division?
Divide. All right, perfect. And we get then x equaling 11, or 11 equals x, which is the same thing. Again, variable on the left side is the way you would end the problem. To be in the correct format.
Now, before we go to the next slide, we did say, though, for those of you that do like to keep your variables on the left side, you can do that. As Mr. Bridges said, it will be a negative in this particular situation, but if you would like to stay consistent and always have your variables on the left side and always have your numbers on the right side, that is perfectly okay. Right? It's okay for you too, isn't it?
It is absolutely just fine. So we would get something like this. Now, hopefully you can see that. You get negative 4x on the left side, and then you'd have negative 44 end up being on the right side. And when you divide both sides by negative 4, you still get positive 11. I didn't make that up. That's real. That happened.
So what are we going to do in equations with fractions? Remember, if an equation is simple enough, you can cancel the fraction by multiplying by the reciprocal. So in this case, the example is 2/3 x equals 26. Well, to get rid of that fraction, let's just multiply by the reciprocal and multiply everything by 3/2, or 3/2. Okay, so what that'll give us is that's a coefficient of the x, so it can be canceled by multiplying its reciprocal 3/2. Also, remember our properties of equality.
I believe that is what you do to one side,
You have to do to the other.
We're a great team, aren't we?
I think so.
Way better than Mr. Dahl's videos.
So by doing that, we would have x times, it would equal 26 times 3 over 2. In this case, that would be 78/2, or 39.
What if the equation is not so simple?
See, this side, we knew we were going to get to a slide like this.
I don't know. Why don't you guys think about that? We're going to go.
Bye.
Just kidding. No, we're back. We'll actually help you guys through this. Oh my gosh. Wow. This is a doozy.
Yeah, you got all kinds of problems on this. You got fractions. You have denominators that aren't the same. What are we going to do with this?
We clearly, because it's typed up right here, that you cannot simply multiply by the reciprocal. So there has to be another I guess, process or something, another way to solve this one. Well, that's where we came up with the least common multiple canon. Just because it's so enjoyable to think about and envision. And for all of you that don't like fractions, you're going to love the canon method. This will actually, and we chose a canon because, it just kind of destroys a lot of things. So we're going to destroy fractions. So stay tuned in just a few seconds. Here we go. We have to now think of, since it's called the least common multiple canon, we have the least common multiple of 3, 5, and 15. So we got to review, what is a common multiple, Mr. Reitman? How would we go about doing that?
Well, I think we have to look and find out how those are divided, and then figure out which numbers work out for each of those particular areas.
So what multiple, right, that's part of it, goes into each one of those. We have 3, 5, and 15. So what is the smallest number that every single one of those can go into?
Well, in this case, it is somewhat easy. It would be 15.
It is one of the numbers, and that would be the first check, is to make sure, hey, is it one of the numbers that's given to us? The more numbers you have in the denominator, the longer it might take you to find that, and that is fine. Maybe if you don't know what a common multiple is, that might be a good time to pause the video and then look it up. I mean, there are examples of finding the least common multiple everywhere on the internet. So we found out that it is 15. So what we're going to do with 15, and this takes us back to the equality part and keeping things balanced, is we're going to use 15 and we're going to distribute it to everything. Because if we didn't, then things wouldn't be equal. So that means, as you can see on the screen, we're going down and down and down to all 4 of these terms. And by doing that, that's going to keep things equal, consistent, fair, and of course, right, which is important. And it also gets rid of the fractions.
Ugly, horrible fractions.
So once you do that, you can multiply again. 15 is really 15 over 1, so you can multiply 2 times 15 and divide it by 3 to get the 10x. Negative 8 times 15 gives you the negative 20. 2 times 15 is 30, divided by 5 is 6. And you can do the same thing for the 7. 95 divided by 15 is 7. Look at this now. It turns into what we just kind of did a couple slides on. This is a bob. This is one of those variables on both sides. So again, which one does it matter? If you want to go to the left, you can go to the left. If you want the bigger number to always win, you can do that too. Let's see what happens. So here, every term in the equation, the only place that is safe for the canon is inside parentheses. That's kind of like a side note. If numbers are inside the parentheses, you can't distribute to those things. Just distribute to the number out front, because think about it. The number out front, whatever that is going to be distributed in there anyway. So if you change that one, you don't need to worry about changing what's inside of the parentheses. That's a very important point. And you can see it's important because there's 3 asterisks by it on both sides. So now,
this would be a great time to solve some equations. So you work on these 2 and pause the video right now.
Hey, we're back. Wow, that was really short or long or
Pretty
whatever.
long, yeah.
Something.
How'd you guys do on these?
I see decimals and fractions. Again, you see the or in there. I'm okay with improper fractions. We just don't want to see mixed numbers, and that may be something you can always communicate with whoever your teacher is. But for us, mixed numbers are a no-no. That was what you used to do. Improper fractions are fine. And then for decimals, we'll talk about the proper way to write it. 2 decimal places if we're going to round. Try to be exact as possible, which is why we prefer fractions.
Was the second problem any less messy? No, not any less messy. Wound up with 73/8 or 9.125.
Or if we wanted to round to 2 decimal places, what do you think that would be?
Still thinking?
What is it? You tell me.
I want to tell you.
9 point something.
9.1.
And then we
And
look
then a
to
2,
the next one.
And so it'll be 9.13.
Well, because it's
Because you
5
have to
or
look to the
higher,
second,
right?
right?
You got to
It's
go
5 right, you got to go to the second
5 or
one.
higher, and then that takes that number and moves it up. If this
Yes.
was a 4 or less, then this would stay at 9.1.
9.13 would be the right answer. That's right.
And if it was
Some
4 or
people like
less,
to do 3,
now he's
right.
interrupting me. If it was less than 5, we'd have 9.12. If this was a 4, 3, 2, or a 1.
So check with your teacher to see how many spots you have to round it up. So make sure you're going to write down any questions you have. Get ready to discuss them in class. If you need to watch this video again, please do so. If you weren't entertained the first time, maybe you'll be entertained the second time.
I don't know. Or if you're confused, well, sometimes Mr. Reitman confuses me. It happens. I confuse myself. It's all good. But I think I have a question. Who's better at doing this, us or Mr. Dahl?
That's pretty obvious.
But he will be joining you on the next video, so good luck with that, and we do enjoy, and I really hope he does bust out Jimmy Butler, because, well, Jimmy Buckets is pretty awesome. And hopefully Derrick Rose.
You never know what you're going to see in a Mr. Dahl video.
The
Yeah. Take care.